the four tissues. We made our way to some extent through the connective tissues. We will talk about the nervous system in much more detail. We will talk about muscle. We will have an individual unit in the physiology section on each of those. Let's look briefly at the nature of the skin, the integumentary system. There's some debate about whether the skin is actually an organ. I think the predominant opinion is it's a very large exterior organ containing many components, so virtually every aspect of the other physiological systems, such as the cardiovascular system, the immune system, and so on, extend into the integument. Many structural components. You can see a picture of a sort of simplified cube of skin there. So we'll talk about the overlying epidermis, the dermis, and then this region down here goes by a variety of names. Subcutaneous fat, campropopsia, hypodermis. We'll have various terms to describe that. And then I think at a couple of points in the slides there's a discussion of the functions of the skin. It's chiefly protective, I think. It acts as a barrier to protect internal systems from the insults and assaults of the outside world. It protects in terms of mechanical protection. It provides some degree of protection against chemical assaults, burns, bug bites, you name it, infections. It also facilitates body temperature regulation through a variety of different mechanisms, primarily through regulation of blood supply through the skin, but also through respiration, hydrosis. To varying degrees, the skin is waterproof. We'll talk about the specialized cells of the epidermis that contribute to waterproofing. And again, to varying degrees in each of us, the skin, more so the dermis and hypodermis, can be reserved for energy. We'll talk a little bit about the role of the skin in regulating vitamin D production. Actually, 3 tissues are involved in generation of vitamin D, but certainly the skin is a necessary component of that process. And then, of course, you perhaps less so than other organisms, utilize the skin for sensory purposes. It's a very important component of our interaction with the world around us. Therefore, we have a number of sensors in the skin that detect everything from temperature and pain to vibration. So let's sort of skip around here with respect to the regions. Let's look at a quick overview here. We have a very quick, simplified picture of the epidermis. The epidermis would be, let me turn my pen on here. The epidermis is this region up here. Below that would be the dermis. So all of this is the dermis down here. We'll find in just a moment that the epidermis consists of about 4 or 5 different layers of cells. We'll talk about the predominant cells in that epidermis, chiefly keratinocytes. That's variously pronounced. I prefer the term keratinocytes, which 90% or more of the epidermis consists of these keratinocytes, and we'll talk about their distribution in just a moment. There are melanocytes that reside deeper in the epidermis, in this region down here, toward what we call the basal layer of the epidermis. And as the term suggests, they play an important role in conferring skin pigmentation. We'll talk about that. The Langerhans cells are specialized immune cells that sort of also reside within that barrier region between the dermis and the epidermis, but they have the ability to migrate superficially. And then Merkel cells, among other types of cells chiefly in the dermis, sometimes extending up in the epidermis. You can see some here. They're a type of sensory epithelium, and we'll talk about the various types of sensory cells that extend into the epidermis. We've already made the point that the epidermis is largely avascular. It, depending on, part of the issue in the epidermis is those keratocytes just have a short lifespan to begin with. They don't live very long, and as they migrate from the basal layer to the superficial, to the exterior, most of the oxygen is acquired by simple diffusion from the air, and then they acquire vascular nutrients by diffusion from a rather intensely, you can't really see it all that well in this illustration, but an intensely vascularized area up in here. In fact, you see some of the capillaries here that supply the dermal papillae. So in the illustration on the right here, the graphic on the right, the slide on the right, I guess, this is the epidermis, and so that you can see it has an irregular border. Everything out here is epidermis. These little projections into the epidermis are called the dermal papillae. And so there's an interdigitating quality. That was unnecessary. Interdigitating quality. I guess I did turn off the light. And then you can see below the epidermis we have two primary structural layers that make up the dermis. There's the papillary area and the reticular area. You don't really see in this particular slide that the reticular layer is much, much larger. It's a much more expansive region than the papillary. Papillary is a relatively minor component. It is the more superficial of the two components and is generally more of a alveolar tissue, whereas the dermis is more of an irregular, dense connective tissue. You can see a list of the cells present in the dermis down here. We've talked about most of these. You know what a fibroblast is, the specialized cell of connective tissue that secretes the matrix, in particular the collagen fibers that we would find in the dermis. There's going to be a profusion of adipocytes in this region, macrophages to lend immunological protection, mast cells, we mentioned earlier, that mediate inflammatory responses in the skin, and a variety of migrating white blood cells. In fact, there are a number of cells in the skin that are loosely classified as leukocytes, although I think a cell biologist might challenge that generalization. Mention the two layers. In this illustration, we begin to see the relative size of the two layers of the dermis. There's sort of the dividing line there. So this is the epidermis out here. Here's our papillary layer of the dermis, and then down here would be the reticular layer. As we've indicated, the papillary layer, loose irregular tissue, usually classified as alveolar. However, you should keep in mind that sometimes what's sometimes called the ret papilla, this region where I've drawn in that red line, let me get rid of that. What you often have in here is a profusion, in this region right here, a profusion of blood vessels, and sometimes a little smooth muscle. That may or may not be there, so you don't always have this significant border between the alveolar and the irregular connective tissue down here. In general, as we've indicated, the dermis is well vascularized. There is significant abundance of sensory structures. We'll talk more about those later, but we've indicated those sensory structures are primarily sensitive to deformation of the skin, vibration of the skin, temperature, pain. We're going to talk a little bit about pain. And then as we've also pointed out, that those fibroblasts are primarily secreting collagen in this region. By the way, notice in the skin, you should be able to tell me if you were to look at an unlabeled image like this on the quiz, you should be able to tell me that that is keratinized stratified squamous epithelium, in addition to being able to point out the two layers of the dermis. Right, there's the keratin up here. Now, I probably would not ask you to identify something like this, but I think it's useful to see, again, the sort of border line between the papillary layer of the dermis and the reticular layer down here. And then you can see once again this is keratinized, stratified squamous epithelium. This is sometimes called the reticular layer because it has a relatively high concentration of reticular fibers. One of the problems you're going to have, more so than I, because this term comes up so often, there are several types of reticular cells or reticulocytes. There's one type that is present in the dermis, and that in part is how it gets its name, because it stains. These fibers are fairly abundant and it stains quite easily. But there are also reticulocytes we'll talk about that are present in this region and more abundant as we move toward the papillary layer that play an important role in the immune system. Over on the right here we have a similar sort of slide, except here the stain is for both reticular fibers and elastic fibers. These dark regions you see, the dark little wisp that you see, strands, are chiefly elastic fibers, and then the reddish regions are collagen. But again, this is the reticular layer here, here's the papillary layer in here, and then above that you see a fairly dark stain for the epithelium, the epidermis. So this is a somewhat more profuse and idealized representation of the skin. Hopefully at this point you can recognize this is the dermis here. You can see the dermal papillae, these little projections from the dermis into the epidermis. And then you also note the profusion of structures that are present in the dermis. You can, for example, see the yellow structures, which are intended to represent sensory structures of one point or another. You can see blood vessels here. You can see the profusion of blood vessels. We see a variety of glands. Notice that some of the glands, such as this one right here, let me point that out again, such as this gland, empties directly into the surface of the skin. And whereas, by contrast, you have another type of gland over here on the right that is associated with a hair follicle. And sometimes the distinction is made between ecrine and epicrine. Unfortunately, this distinction isn't always observed. But when it is, the ecrine gland basically proceeds directly to the surface of the skin, whereas the apocrine sweat gland is more consistently associated with the hair follicle. Yeah.
Is there a difference between ecrine and epicrine?
One of the questions you could have asked, that's the least desirable. Because, and I say this only because the terminology is inconsistent there. So, what has been found is that apocrine secretion now is chiefly merocrine. But apocrine secretion, again, used in more of a clinical context than histological context, remember, that refers chiefly to axillary structure. So I don't know what to tell you there, except that there is that ambiguity and confusion. But when there is this type of discussion in the histology, it's usually this type of distinction. It's usually between glands that influence directly into the skin and glands that secrete in association with hair follicles. But in terms of the mechanism, it's chiefly merocrine. So I think that covers most of the structures, and we'll talk a little bit more about the organization of the hair follicle in just a moment. You can see once again the hypodermis down here, the subcutaneous fat tissue, which is going to vary significantly from individual to individual. Now what we're looking at here are more or less the underlying planes along which the collagen fibers in the integument are organized. And so why would this be important for a PA to know? Why would you want to be aware of what are called Langer's lines, tension lines, Kressel's lines? They go back already.
Decisions to make?
I think so, yeah. I mean, especially if you are concerned about the cosmetic consequences of your incision. Sometimes you are, sometimes you're not. It really depends on a lot of factors. But in general, the incision in the skin, if circumstances permit, should be parallel to the collagen fibers, parallel to the tension lines. That tends to minimize the likelihood of scarring thereafter. As I say, there's a great deal of variation in the terminology. I did move the slide around. I guess it didn't take. I had another slide I wanted to show there. So, of course, skin varies dramatically in terms of its pigmentation and color. This is largely a consequence of the levels of melanin in the skin. So, melanin, excuse me, someone has taken over the other computer here. Melanin is released by melanosomes. We saw the melanosomes in a previous illustration. For the most part, reside at that interface between the dermis and the epidermis. The melanocytes produce melanin, derived in turn from tyrosine. Through organelles, the lymphocellular organelles called melanosomes. As it turns out, we all have approximately the same number or relative abundance of melanocytes. What differs in each of us to a larger extent is the relative abundance of melanin and melanosomes. So the relative abundance of the melanosomes will determine the relative degree of pigmentation. It might be useful to keep in mind, again, this pathway from tyrosine, because that will come up later, especially in the physiology course. There are several different types of melanin. I mentioned two of them here, pheomelanin and eumelanin. The eumelanin is the more common type. Of course, the abundance of melanin in the skin serves to some extent as a protection against damage from UV radiation. So one would expect individuals whose ethnicity and background was in a more tropical region to have greater degrees of pigmentation, or at least, again, as we define that in terms of melanin. Now, is there any disadvantage to darkly pigmented skin with respect to physiology? For example, we've indicated that greater degrees of pigmentation in general, if we're just talking about melanin, tend to be more protective against UV radiation. Is there any downside to that you can think of? Yeah.
It's harder to make vitamin D.
Exactly right. So that's the only point I was wanting to make here, is that there is a bit of an adaptive trade-off between protection against UV radiation and the ability to produce vitamin D, because melanin tends to inhibit that process. So if that's true, in a climate, let's say in Scandinavia, who is more likely to suffer, or who is more likely to be in need of supplemental vitamin D? And boy, that's another hot topic. Supplemental vitamin D, a dark pigmented person or a light pigmented person? Yeah, so I just want you to see the relative. Whereas the light pigmented person is going to be in trouble in a more irradiated region of the globe, just because of the additional risk of skin cancer. So I indicated these melanocytes are present. This would be a dermal papillary here, bottom, dermal papilla. And then this is the melanocyte that you see here. And what the melanocyte can do, we'll have some better illustrations of this. We'll have some clear representations. But that melanocyte can do two things that are, I think, a little different than the other cells around it. Number one, it sort of interweaves itself, interdigitates itself between the adjacent keratinocytes. These would all be keratinocytes here. And the other thing that it does, and this is important for hair as well is these pigmentation granules, again, the melanosomes and their contents, can be conveyed to surrounding cells. So while the melanocyte generates the melanin via the melanosomes, both the melanosomes and the melanin can then be taken into surrounding cells. True for the hair as well. So we're talking about melanin here. I just want to make sure you understand. I've used this slide. I probably won't do it for you, but I've used this slide on tests in the past. And I've asked what is stained, what is being shown by the stain in this slide. And I've always, I guess, been a little too hopeful because there are a number of things you should be able to identify. First of all, what type of epithelium is this?
Keratin.
It's keratinized stratified squamous. And so the keratin would be up here. This would be our epidermis here. And so what would this be?
Basal layer.
Yeah, that would be the basal layer, but it's also it's a stain for the melanin. And that's just telling us that the melanin is much more abundant along that boundary between the dermis and the epidermis, because that's where the melanocytes are. There are a number of other factors that influence skin color. For example, the degree or extent to which the integumentary capillaries are near the surface of the skin. One reason your lips are pinker than the rest of your skin is because the epithelium, the epidermis, is thinner there. But certainly hemoglobin, you know that you can become flushed when you are too hot or too cold. At least various portions of the skin may respond to thermal changes in that way. What is erubescence? Anybody know what it is? Sometimes, it used to be fashionable to erubesce. I'm not sure that's true anymore. Erubescence is blushing. So what do we mean by blushing? All right, the skin of the face becomes a reddish. Can anybody explain to me the cause of blushing? When I say cause, I'm not really. We've indicated that it's a change in blood flow to the integumentary capillaries. But why do you do it? Have none of you ever blushed? All right, so the answer was because you're embarrassed. Well, I guess, why would that even be adaptive? In other words, why would you, let's say you are embarrassed, let's say you've done something awful, shameful, and there's somebody, or maybe you're just, I don't know, we can all think of a variety of reasons this might happen, but why would it be adaptive? Can you think of any reason? Yeah.
Isn't it kind of a part of like your flight response, because when you get into like a stress situation, your temperature rises, so the capillaries on your face or
I think in some cases that happens, but that would be a more generalized, general response. When we talk about erubescence, my heart rate could be fairly normal, but my skin of the face may nevertheless redden. So I think while that may happen in some cases, it doesn't necessarily happen. I was actually just looking for some answers here because we frankly cannot, there's no known adaptive value to blushing. It's basically, if you look at the anthropological literature, it's almost counteradaptive. It's saying, you've seen two dogs get to fight two wolves and one will bare the throat. It's like saying that I've done really bad now and I'm owning up to it and I'm admitting it to you, and probably I'm putting myself in a submissive position. Otherwise, why would you do that? It's not like a mating response that you see in fish or in some apes. I don't know if anybody can come up with an adaptive explanation for blushing. I would be interested in hearing it. Except that it says maybe it is part of the mating response. At least in my experience as a young fellow, I can tell you stories, but it didn't work out to my benefit. Is what I'm saying.
Professor, how do you spell the erubescence?
E-R-U-B-E-S-C-E-N-T.
Can you spell that?
E-R-U-B-E-S-C-E-N-T. I have to do it.
Green is red. So if you get nothing else from the course, you can.
Yeah, just that.
Blushing. I remember reading several stories of, I remember one case several years ago, it's been quite a while now, a young lady who was physiologically dependent upon Sunny Delight. Anybody familiar with Sunny Delight? It's sort of a orange juice-ish. I don't know what actually it's made up. I'm sure there's a high concentration of high fructose corn syrup in there. Beyond that, I'm not sure. Probably food coloring, and probably some sort of addition. It's probably every sweetener you can think of. The food coloring, there probably were some sort of byproducts of citrus fruit production in there as well. Probably one of you has stock in Sunny Delight. I'm going to get sued tomorrow, but in any case, I remember that individual skin turned orange. Right? It was just the abnormal amount of carotene in her diet that will do that. Yeah.
My grandma remarried to this guy who ate carrots non-stop, and he was orange.
Well,
Orange.
what about eat the carrots? They're not that good, you know.
He's kind of weird.
But you get the point. So dietary intake of carotene can also affect food. When I was young, I don't think they do this anymore, but there used to be this suntan cream called QT or something. I forget what it was called. But you could rub it on places, you could rub it on your skin, and the assumption was you'd be approximating a tan. No, you just look like you just were yellow. Is what you were, an orange yellow type. So it didn't look anything like a tan. But that too was a temporary carotenoid that was taken into the skin. There are many other causes of abnormal skin coloration. Albinism, there are many types of albinism, but it refers to a genetic deficiency of pigmentation. I think as a PA, the primary thing to keep in mind about cases of albinism is that it affects not only the skin, portions of the integument are embryologically derived from the same neural crest tissue that gives rise to the nervous system. It is often the case that albino individuals suffer a variety of neurological issues as well, visual and neurological issues. Vision may or may not be impaired. They usually have blue retinas, not pink, by the way. There may be problems with motor regulation of the eyes. That's not uncommon. They'll often have trouble perceiving color correctly. But I think the larger point that I'm making here is that there may be other neurological issues that may warrant more consideration than the change in skin. You may be aware of the horrifying things that are happening in some regions of Africa to the albino individuals there. So other causes of abnormal skin coloration, hyperpigmentation, such as, for example, occurs during female pregnancy, can occur during certain endocrine diseases, Addison disease, for example, sometimes Cushing disease, can cause sufficient abnormality of the pituitary axis. We'll talk about that later, but that can result in increased expression of ACTH, for example, adrenocorticotropic hormone. Jaundice can show up, hyperbilirubinemia can show up in certain types of liver disease, which is the usual cause, but this would impede the disorders of the spleen, sometimes the immune system, but this is a condition in which the normal ability of the body to recycle red blood cells is impeded. We've talked about carotenemia. There can be many causes of carotenemia, both intrinsic and extrinsic. Cyanosis, sort of a bluish tinge, basically hypoxia, basically insufficient blood. We'll talk about the various types of hypoxia a little later. But cyanosis is sort of a bluish tinge that may result from insufficient circulation to a region of the body. You know, there are a number of metals that, in general, heavy metal coloration can be an indicator of more important problems. Most metals are neurotoxins. But you do have a few that have actually been used over the years for therapeutic purposes. The fellow in this video just passed away, I think, either last year or a couple of years ago. But we won't watch all of this. Just hold on a second. Anybody familiar with Papa Smurf?
Line. Paul Carson has learned firsthand it's not always easy. You see, Paul is not a stranger to glances and stares ever since his skin began turning a fairly bright shade of blue. And Paul joins us this morning along with his girlfriend Jackie Northrup and NBC News Chief Medical Editor Dr. Nancy Smith. Good morning to all of you. How you doing, Paul?
Okay.
You know, people are watching right now and they're saying, you know, yep, his skin is blue.
Yeah.
And and they want to know how it happened. Give me the brief version of how this began.
I put colloidal silver directly on my face.
Because you had some severe skin problems about the time of the death of your father, some stress related. You had some peeling and cracking and irritation.
That's right.
And so you put colloidal silver. Can you explain to people what that is?
It's just a liquid that you make through electrolysis with silver and distilled water.
And how did you decide to use this? Where did you hear about this? Did a doctor tell you to do it?
Oh, no. I did it all on my own.
How'd you find out about it?
Originally, I just saw an ad for a colloidal silver generator in a magazine.
So I was going to show, there was a picture here. Yeah, there he is before.
What?
Or do you avoid people in some ways?
Oh, I do tend to avoid people in some ways, but then I always did. I've always been sort of.
So I think, I don't know what the cause of his death was, but I don't know that it was directly related to his toxicity. In any case, they called him Papa Smurf.
Just be opposed. Can I get the...
There we go.
Damn.
No. This was an ongoing. That's why the interviewer was so surprised. This had to be a lifestyle. And as was pointed out in the video, he not only applied it to his skin, he drank it. So it was systemic.
Well, at least his skin was intact.
So would the same thing happen if they use that?
So the question was about the legitimate therapeutic use of colloidal silver. In some cases it's used. In some cases, I don't recall, colloidal gold. There are suspensions. By the way, do you remember from your chemistry what a colloid is? Do you remember that about the second week of chemistry?
Isn't it like the particles are suspended and they separate?
Yeah, it's in an intermediate mixture at which they are not quite in solution, but they don't tend to sediment as readily as heavier particles might. We call that a colloid. We won't get into some. It has some interesting chemical properties. But in any case, when we talk about a colloidal suspension, there are some cases, there are certain skin diseases it's been used on, both topically and systemically. But with all of these, as I've indicated, the major, if you're familiar with an LD50, there's a therapeutic dose for just about everything. But if you exceed that, it's going to be even true of water, right? It can be lethal. And so for heavy metals, or metals of even this type, whereas it may be helpful in some cases, it could be neurotoxic, could have other toxicities beyond that. Now, certain heavy metals, such as Anybody ever heard of Paracelsus back in the 15th century? His cure of everything was mercury.
Yeah.
And I remember as a child, it was nothing to get the mercury. We'd take it to school, we'd play with it, throw it at each other, put it in our hands, and all sorts of things. Maybe you can see some consequences of it. When we would get the lead shot, we would go fishing, we would bite down on it to anchor it to the fishing line. No intelligent person in here would do that now. But we proceeded through life in a great degree of ignorance. But my point is, a lot of these metals are really not safe at any level. So it really depends. But certainly colloidal silver has been used along with some of the others to deal with most of the integumentary conditions, but not in the amounts that he was taking. All right, let's talk a little bit about the organization, the structure of the epidermis. As one of the earlier slides indicated, there are 4 or 5 layers depending upon the region of the body we're talking about. Here we have 5 layers listed, proceeding from the innermost. That's the basal layer. That's the innermost layer, stratum basal or germinativum. It's called the germinal layer because this is the area of greatest mitosis. As we indicated, these epidermal cells are being rapidly generated, and they die as rapidly as they're generated. As they migrate from the basal layer, from the dermis toward the surface of the skin, they basically flatten, become enucleate, that is to say they extrude the nucleus, and become progressively more moribund. They lose their vitality. And so to sustain this process, there's a very active and rapid regeneration of cells at the basal layer. And as we've indicated, those cells actually have a more cuboidal appearance, and it's only the surface layer, the outer layer, that's more squamous. Most of the cells are keratinocytes, but we typically call them stem cells. These are very limited stem cells. We don't have time to talk about the different types of stem cells in here, but some stem cells can become any other type of cell. Other stem cells can only become a few, have a narrow range of differentiation. So these are what are called oligopotent, very limited stem cells, and for the most part just become keratinocytes. Superficial to the basal layer is the spiny layer, stratum spinosum. The layer gets its name from the fact that the desmosomes, the proliferation of desmosomes, attract stain and give the cells a sort of spiny appearance in histological preparation. There are usually about 8 or 10 layers of these spiny keratinocytes. Remember, about 90% of the cells in the epidermis are keratinocytes. Exterior to the spiny layer is the granular layer. This is important. It's relatively thin. These are mature keratinocytes, and at this point they begin to be enucleate. They begin to become more moribund. And as these cells progressively involute, progressively lyse and break apart, they release hydrophobic glycolipids. These glycolipids that we encountered previously in a discussion of membrane proteins act to waterproof the skin. So the most protective region in that respect of the epidermis would be the granular layer. And as I say, this is really where they lose their vitality for the most part. The clear layer, the stratum lucidum, may or may not be present. This would be present in the regions of the skin that undergo heaviest use. So, for example, the soles of the feet, the palms of the hand, for example. And those keratinocytes are quite dead at this point. They're just basically husks. And exterior to that is the final layer, the stratum corneum. Corneum just implies hardening. In fact, the keratinocytes at this point, the keratinocytes at this point are just called corneocytes because they're dead. They're really not vital cells. They're just acting as a protective layer. Highly variable in density, 20 to 30 layers, typical. But they retain that glycolipid that was extruded in the granular layer. So again, waterproofing is present throughout. Yes?
Just kind of random question. Have they found stratum lucidum anywhere else other than the palms and the soles? on a non-diseased person?
My guess is, a question like that, I can almost always answer yes, without having any factual knowledge to back it up, because it's so open-ended. I would think that there would be a number of, for example, in your dermatology lessons and in your dermatology rotation, you're going to encounter all types of keratinoses. And keratinoses imply some accelerated growth and over-distribution. It happens with aging, it happens with sun exposure, it happens in a variety of pathologies. My guess is in certain types of keratinoses you would have that as well. But for our purposes, we're referring to this stratum lucidum as a thickening under the corneal layer where the skin is most abraded, where it is most active, and so on. If you ever looked at the fingertips of a guitar player, it would be very typical. So we have a number of illustrations here showing the layers, and again, those orange cells that you see there, those are the keratinocytes. Here would be a dermal papilla here. Here's our melanocyte. The melanocyte is the green thing there. You can see it extruding its little processes around the adjacent keratinocytes. Bear in mind that as it does that, it's conveying the melanin to those cells and altering their color. Merkel cell is a type of sensory cell, sometimes called the receptor of the skin receptor. In fact, we're going to learn there are a number of these. The slow adapting receptor, sensitive primarily to deformation of the skin. But you can see the little lines in between the keratinocytes. You can see that in the spiny layer, there are lots of cell junctions, and the cells, for the most part, still have their nuclei. In the granular layer, they're showing they're not showing the cells dying here to the same extent, but those little red dots represent the glycolipids that are being extruded from the cell, conferring the waterproofing. And then outer, this being apparently a heavily used region of epidermis, we can see the clear layer of stratum lucidum, and then the husks of the keratinocytes. And all of that huskage, that's a technical term, what is that made up of? Yeah, keratin. Remember, the keratin is a type of intermediate filament. Yes, sir.
So is that area around the melanocyte, is that the melanoma?
No, you really don't see the melanosomes. Remember, we talked about liposomes and endosomes. So the melanosomes usually are just intracellular vesicles that are extruded from the cell. When that happens, we call those vesicles, the usual clinical term is granule for some reason. Those are called granules. And so by various mechanisms, the contents of those vesicles are taken up. Of course, they're going to have the ability to merge with adjacent cell membranes, and their contents can be taken up, I suppose, primarily through relative concentration, just diffusion and so on. Another illustration showing the same thing, except here we can see these are the melanocytes down here. By the way, remember which of these layers is most actively mitotic?
Basal.
Yeah, so you can see the basal layer down here. You can see a little what's called in histology a mitotic figure. We can see the melanosomes having been passed into the surrounding keratinocytes. We can see the cell junctions and the spiny layer there, those little dots that you see. Here's our Langerhans cell. This is a specialized immune cell of the epidermis. Probably migrates there from the dermis, probably a differentiated monocyte. And what I didn't mention, I probably should because it's really not in the notes. We think of you look at these keratinocytes and you just see them as sort of placeholders, protective placeholders. But in reality, what has been shown over the past decade or 15 years is these cells are extremely important immunological sentinels. They are constantly monitoring the environment, and if a pathogen is detected, if something that shouldn't be there, something that is foreign, is detected, they release a variety of cytokines and various other immunochemicals to generate what? An immune response. And in fact, some of these keratinocytes, in response to challenges from the outside, will undergo apoptosis. What is that? Right, program cell death, and that in turn will initiate an immunogenic response or an inflammatory response. By the way, the fellow who came up with that term is actually a team. When I was in graduate school, we didn't quite know how to pronounce the term. He pronounced it apoptosis. So, if I were to show you the image on the left, at the very least, I would expect you to be able to point out the corneal layer. Remember, the keratinocytes are also called corneocytes, the process whereby they lose their vitality as they migrate to the surface is called cornification. Corn, and then ification. So this would be the corneal layer out here, granular layer, very thin layer. Spiny layer, I wouldn't expect you to, unless we had a specific stain for the cell junctions, and then the basal layer you should be able to identify simply because of its proximity to the dermis there. Corneal layer here, lucidum, you can see the little bars there, the lucidum, granular, and then down here is the spiny layer. So a lot of these layers are going to depend on the histological stain that was used. But again, be able to identify the dermal papillae that you see here. Anybody ever purchased a mattress topper? So think of the interface between the dermis and the epidermis as like the mattress topper that has a little projection sticking up. And of course, certain regions of the skin have higher ridges than others. Where are the dermal papillae going to be most prominent? Right, don't you have your fingerprints here? You can almost see the dunes, the ridges, but you don't see them in this region. All right, so we've talked about the general migration from the basal layer to the corneal layer. And we've talked about some of the special properties of the keratinocytes. Keratin is sometimes in the text you will see reference to pre-keratin and keratin. Technically, the intermediate filaments are pre-keratin, but that's more of a scholastic distinction. Here we've talked about the glycolipids that act to waterproof the skin. We've talked about the fact that stratified epithelium is named for the most superficial layer, therefore we describe this epithelium as stratified squamous. And we've talked about the importance of the melanocytes, the Langerhans cells, but keep in mind, while the Langerhans cell is a epidermal macrophage, it is not the only immunological cell in the epidermis. The keratinocytes play a very important role. In fact, some of those articles describing the immunological responses of keratinocytes are quite complex. And then keep in mind that there are a number of neural structures, a number of sensory structures in the integument. The reason that you see reference to the Merkel cells with respect to the epidermis is because the Merkel cells sometimes sort of actually extend beyond the dermis into the basal layer of the epidermis. Plus, they're quite large. So we've made a distinction between skin that is very much used and skin that is less prone to mechanical abrasion and so on. There's also a distinction between hairy skin and hairless skin. Hairless skin is sometimes called thick skin or glabrous skin. The hairy skin tends to have a thinner general overall organization. But let me just make this point and we'll take a break. The skin that is associated with a higher abundance of hair has fewer dermal papillae, whereas hairless skin, especially in the region of the palm, the region of the fingers and toes and so on, have rather thick ridges that in part arise from the very prominent dermal papillae. So let's take a break, but as you take your break, I would ask you, why do you have fingerprints? What is their adaptive value?